Muito. To the bottom. Let's check. Okay. One more time. Okay. People waiting. Wow, man, I tell you. Everybody sign the roll. Why did I do a wait a minute?
Nanti.
What you working on, Jay? Oh, the stuff. Okay, this one. Dang, you don't.
to Zoom. You have not entered any numbers.
I know what you mean, too. Did they just say food?
Welcome to Zoom. Enter your meeting ID followed by pound. You have not entered any numbers. Please re-enter. Welcome to Zoom. Enter your meeting ID followed by pound.
You want to go outside and shoot to these shots for Will? You shoot 5 and I shoot 5. Oh, yeah.
Ma, how I do this thing again? How to do this phone thing again?
You called it with a number? Dial. I think I used the second one last time. Oh, what's the first one? Try the first one.
The first one saved up in here.
Oh, okay. Wait. And then you use the first one. And it's gonna ask you for.
Welcome to Zoom. Enter your meeting ID followed by pound.
The conference.
You have not entered any numbers.
We can't hear you, Mr.
Oh, now it won't work.
You got us muted.
Oh, this is why he muted us.
Oh, pound.
Well.
This is Sylvester
Oh.
your thing. We can't hear you.
There are participants in the meeting.
Right.
If the participant on hold by
You was I texted you and told you, but we can't hear you. I can read your lips. We can't hear you, Mr. Sylvester. We can't hear you. Let's see. I joined with audio.
You are muted. You are muted. You are muted. You are unmuted.
What?
What cup, man? What cup? Mr. Celeste, I think you made a mistake and press the mute button on your Zoom phone.
You are muted.
All right.
Here you go.
Mr. Robinson. Signing up there. Okay. So hopefully it's better. Okay, I'll leave it like that. All right, class. Let's get back to the class. All right. Now, I'll close this up. Clean this chat up. So everybody can hear me. So now, we was talking about the plus, plus, minus, minus. So you probably can run these programs, type in these programs and test them. Like I said, you got to make sure you don't get any errors because a lot of times when you type in the code, you might mistakenly miss a character or so, right? But the plus, plus, and minus, minus allows you to add one or take away one. But what based on it being pre or post determines what is done and when. Look at this. Int x equal 1, int y. Y is equal to x plus plus. So y is equal to what? 1, because it's postfix. Here, int x equal 1, int y. Y is equal to plus plus. Now you need to mute one of those things. So you get y was equal to 2. Put that. Okay. Now, somebody is giving feedback. Either you have a phone that has a recording, and a computer. You're doing it on the computer and the phone or something. And I could hear it coming back to echoing through the. Okay. Now, I still can hear that echo. Somebody who's watching the Zoom twice, either on a phone and a computer, or you need to just mute or whatever. Just mute until you're ready to talk.
Jason, mute your phone.
Turn the volume down or something, All right. Now, so it's telling us now we can use the plus plus even to use in regular expressions. And look here, you got C equal A times B plus plus. In this situation, B will not change. So A will be multiplied times 5 to get 10, all right? In this expression, C is equal to A times plus plus B. In this expression, B would be multiplied, added add 1 would be added to B, which makes B 6, and then it multiplies by 2 to get 12. So you see the difference. Now I'm telling you here, you cannot do a plus plus to an expression that has a left and a right side. You have to solve either solve with plus plus A times plus plus B. You can't try to do an expression and do a plus plus on that entire expression. That will not work. All right. Look at this. Now, in this example here, would this be true or false? We setting x to equal a 10. It says if x plus plus is greater than 10. This is a valid statement. So x is equal to 10. So this would say if x is greater than 10, this would be false. Because what? At the time it acts in the if, this is post. So x would still equal to 10. So 10 is not greater than 10. So therefore it would not execute this statement. But if it was if it said if plus plus x is greater than 10, then it would output x is greater than 10. All right? So those type things. So look here, see, if plus plus x is greater than 10, yes, it is, and it would output. So like I say, you can do these checkpoints, questions, and test your skills and whatnot. All right? The while loop, okay? The while loop is a loop that allows you to perform statements multiple times. You, the programmer, will determine how many times a loop is performed if you have a count in it. But you can write a loop to where the number of times that a loop performed is determined by the user, okay? So let's first of all do one that deals with a count, all right? And this information here tells you about the loop, the format of the loop. You got while, whatever the expression, could be x less than 5. And if it is, you're performing a statement or multiple statements. And those statements could be enclosed in curly brackets, all right, or would be in curly brackets. So now, let's go back to our online GDB and let's do a while loop, all right? So here I could say, for a while loop though, I'd have to have a variable, okay? I'll say int x is equal to 0, okay? So I have to have some kind of test, all right? Now I could say while, okay, x is less than 5, all right? And then my curly braces, I want to do something. Whatever it is I want to do. But looking at this loop, all right, what I want to do, I can say cout. I'll do this first. Just go down 2. All right, I'll just go down 2 lines before we start. So cout, all right, and I'll put all right, BRCC. So now a loop, you need 3 things. First of all, you need a starting point. You need something, a variable that's declared to be something. So we did int x equals 0. That's our starting point. We say, okay, here, while x is less than 5. So now we're going to test to see if x is ever get to equal to or greater than 5. But in this loop, we need to do something to where x is what? Approaching what? 5. So in doing that, we would increment x by 1, which would be what? X plus plus, or either x plus equal 1 or x equal x plus 1. All right? Either way you do it. All right, we went over those 3 statements earlier. So what happens, we have a starting point, starting at 0. We say while x, okay, is less than 5. Is 0 less than 5? Yes, it is. What we're going to do, output BRCC, increment x by 1. X becomes what? 1. Is 1 less than 5? Yes, it is. All right, it's going to output BRCC for the second time. Increment by 1. X becomes 2. Is 2 less than 5? Yes, it is. It's going to output BRCC for the third time. It's going to increment by 1. X becomes 3. Is 3 less than 5? Yes. It's going to output BRCC for the fourth time. And then it's going to increment by 1. Then X becomes 4. Is 4 less than 5? Yes, it is. It's going to output BRCC for the fifth time. Increment by 1. Is 5 less than 5? No, it's not. So it's going to kick out the program and continue on. All right. So I could say, I could do something like this. Program complete. All right. Okay. So if I run this, all right, run it. Hopefully we got all the errors out. All right, look here. 1, 2, 3, 4, 5. Program complete. All right. So we allowed the program to, execute these statements what? 5 times. So I can even say, okay, well now, I don't want it to perform 5 times. I want it to perform 20 times. You simply would change this. So see how you can modify your program so that what code can be written where you don't have to keep rewriting code over and over and over and over again. So that will perform that 20 times. So what I'll do here, just to let you see what it actually is doing, I'll do this. Okay, I'll do something like this. I'll leave a /t. All right, so that's going to show you what X is each time it prints it. So we run it. See what happens? X starts at 0 and end at 19. 0 to 19 is a count of 20. So don't get confused. See, we didn't start at 1, we started at 0. 1 to 20 is 20. 0 to 19 is 20. You got to remember, we as humans, we always start the count as 1. In computer science, the computer always starts at 0. And you kind of understand that once you start getting into arrays and vectors and whatnot. All right. So that is 20 times and then it stops. So see how either you can modify your program and do something X number of times rather than trying to rewrite code over and over and over again. All right. I could even modify it to say, okay, I don't want 20 times. I just want it to perform 2 times. All right. And run it. And bam, it ran 2 times. But simply what? Controlling how going from 0 to less than 2. All right. You control that. All right. Any questions about the loop? Now, inside that loop, you could have if logic, you could have any valid C++ statements that you can use in a program can be inside that while loop. So while whatever, I want to do this, all right? So you can have statements that you want to perform, okay? Now, if we go back to the program, and it shows us this while loop. What we had, int number equals 0. That's our starting point. Okay, while what? Number less than 5. What that says, not less than or equal to, but less than. Less than or equal to 5 will allow that loop to perform 6 times. But less than 5 starts at 0 and end when number is equal to 5. But then we had to what? We had to increment number so that number can what? Reach 5. Now, if we would not have incremented X here, where they incremented number, so I put a comment here. What you think would happen to our program? It will be caught up in an infinite loop. That means it will be continuously running and never stopping. Most compilers or most programs would kick you out after a certain amount of time, okay, because they give you a certain amount of time limit to run the program based upon its estimation of its execution time. And if it goes beyond that, it'll say, oh, aborted, program exceeded the time to run. All right, or something of that nature. So watch when I run the program this time where what? What's going to happen? Let's go through it. X is 0. X 0 less than 2? Yes. Output BRCC. This is commented, so X is still 0. Is 0 less than 2? Yes. Output BRCC. Come back here. 0. 0 less than 2? Yes. So when will X change to approach 2? It will never. So it's going to always what? Perform. So let's run it. Look, X is continuously 0. You can't really see the output because it's all the same output and it's just scrolling up. All right. So it's continuously performing that loop. All right. I can't hit anything to break out, whatever, because the program is steady running. All right. I would have to either break it or do a stop to stop the program. And I just hit the stop to get out of the program because I'm caught up in an infinite loop. All right. So you got to watch infinite loops. This is not the only way you can have an infinite loop. I can do this. X minus minus. So what I'm doing when I change X from that statement from X plus plus to X minus minus. Well, what I'm doing is rather than approaching 2, I'm approaching negative infinity. So anything going toward the negative infinity side will never be greater than 2. So therefore, my loop will still be continuously performing. And so let's run it now. See here? It didn't got to negative 6,000, well, negative 14,000, whatever. All right? And it should continue to perform until you break out of it or the computer breaks out of it saying, hey, you've exceeded your time. See, negative 37,000. So what happens is it's going to continually perform because X will never reach 2 or anything greater than 2 because we go into the negative side. Okay? So you got to remember when you're writing your code, you have to control what's going on. Like I say, your starting point, all right, what's your condition, and whether you're incrementing or decrementing, okay? So you got to be careful. You have to be very careful. Now, another thing about loops, it doesn't matter where you start or where you end. It doesn't matter whether you're incrementing or decrementing because, and I say that because if I go from 0 to 5, or 0 to less than 5, or I go from 95 to less than 100, I'm still performing a loop, what, 5 times? Okay, example, I could make this equal a 95, and I could say less than 100, and then increment by 1. I'm still going 95, 96, 97, 98, 99, kicking out at 100. So I'm still performing a loop, what, 5 times, all right? Or if I wanted to go from high to low, I could go from 100 to greater than 95, all right? But then I have to do what? Minus minus. So see, and everybody don't think the same, or sometimes people write logic in a reverse order to kind of like add confusion to their program. They know what's going on. They know how it works. Because if I go from 100 to greater than 95, 100, 99, 98, 97, 96, kick out at 95, right? So either way it go, your program will work, all right? So if I run it and see, we have it 5 times. 1, 2, 3, 4, 5. So you, the programmer, have to know what you're doing within the program. And I'll tell you, it's going to get very confusing because you're going to have to learn this, The information you learned in 192, you got to keep on learning this information because it's going to get more and more cumbersome. So practice, 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 practice. You got to practice it. All right? You got to practice it to know it. All right. So those key things, the initialization of the variable, all right, giving a starting point, the test expression, and then what? Whether you're going to increment or decrement to reach your goal. All right. So, and this is just example showing what we just did. All right. Numbers less than 5, we print out hello, incrementing, but it started at 0, and they're going to increment till it get to 5. When it get to 5, it kicks out. All right. And this is the flow chart. All right, you have your num initialized at 0, somewhere up here. They don't have it, but it said num less than 5, 0 less than 5, yes, print out hello, add 1. 1 less than 5, yes, print out, add 1. 2 less than 5, yes, print out, add 1. 3 less than 5, yes, print out, add 1. 4 less than 5, yes, print out, add 1. 5 less than 5, nope, continue. All right, so that's all this flow chart is doing, showing you exactly what we went through with the program. All right, so now look at this. It tells us that a while loop is a pretest loop. All they're telling you is before you fall into the loop, you have to test it to see if it's true. And if the expression holds true, then you perform in those statements. So it's just saying that statements in the while loop cannot be performed unless it is tested prior to falling into the loop. All right. So if this, you have to test before you can execute this to see if it's true or not. All right. So that's all they're telling you there. We talked about an infinite loop. This one, look, why do we have an infinite loop here? Just like we did. We commented out num equal num plus 1. When you comment that out, it's just doing what? See out hello, 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 and it never what? Increment num to get to 5, so it's an infinite loop. All right? But what? Once you put this in here, num plus plus, now it goes from 0, 1, 2, 3, 4, 5, it kicks out. All right? Anybody have questions about the information we went over so far, the plus, plus, minus, minus, how they operate, the loop, the while loop, how it operates. We know it's a pretest loop, right? So now, and it say don't forget the brackets, right? Now what they're saying is, look here, you gotta have your curly braces here. If I take the curly braces off here, I'll have an infinite loop. You say, well, Mr. Investor, that's the same statements. Yes, but I will have an infinite loop. And I'll just bring this back to 0 and bring this back to 5, less than 5, back to our original. And then what I'll do, I'll take this off, all right? All right. Now, when I take that off, remember when we did the if statements? And by default, it performed the very next statement of an if? And you didn't have to put curly braces. The same holds true for a while. If I don't put the curly braces, by default, this is the only statement that's in the while loop. So therefore, what? It's going to say, okay, is x less than 5? Yes, I'll put this. Go right back. X less than 5? Yes. It will never do it should be plus plus. It'll never do the plus plus because by default, the while loop will only perform what? That one line. So it will stay outputting BRCC X is 0, BRCC X is 0. All right? Because what? It's never getting to this X plus plus because it's not grouped, all right, with the curly brace. So you got to remember, all right, you have to use those curly braces, and I need to stop it, otherwise it'll continue, all right? So I have to do what? What I want to perform for the while, I want to start here, and I want to end here. So I want to perform more than one statement. So I have to embody them in the curly braces, okay? Very important, right? And most times I would just do the curly braces and do whatever, all right? Because I could do what, X plus plus, but I'm not doing anything else, all right? And it'll kick out, and it'll, if I say an example I'm trying to tell you is if I take this out, all right, and I do something like this, well, I'll just put it like this. If I did something like this, take this off, it should be open. Well, I'm gonna take it off. And I'll do something like this, X plus plus, take this off, all right? And take this one out. All of a sudden now you're saying, oh, well, I got my plus plus, and what it's gonna do is gonna do this and do that. Nope, what it's gonna do is gonna do this 5 times. It's gonna say, wow, X is less than 5, yes it is. Well, semicolon. Increment by 1, come back, 1 less than 5, yes, come back, 2 less than 5, yes, come back, 3 less than 5, yes, come back, 4 less than 5, yes, come back, 5, no. See out this, then see out that. So it's just gonna see out BRCC 1 time, and it's gonna print out X, which is gonna be 5, all right? Because it's only gonna do that 1 statement for that while loop because there's no curly braces, all right? See here, X is 5, because when it kicked out the loop, it was 5, print out BRCC, and then it printed out program complete. All right, so you see how just those minor details can cause issues with your program. All right, so you got to make sure you understand how to write the syntax for the program. Because like I say, once you get into the upper level, 194, getting your Javas, you're going to have to go through that logic, know what's going on in that logic, go through those loops and make sure they're doing what you want them to do, you know, based on what the instructor gives you. All right, so let's get back to the notes, all right? Style, class. This style, I would say never write code where everything is on one line, never write code where your curly braces is all lined up, all in the same column. Now, is it right? Is it wrong? It's not, how would I say, it's not wrong because the program will still run. It's wrong in a sense that it will make it difficult to debug and difficult for somebody to come behind you and evaluate or look through your program to see how it performs. All right, so that's the only thing. So I would tell you, make sure that you try to write code in a fashion to where it can be, pleasing to the eyes. And I gave this example the other day to my other class. When you have a term paper to write, the teacher may give you a font to use, a line spacing to use, a page margin to use, and all that for a specific reason, so that it's pleasing to the eye, it's better to read, etc. And you could have a paper that has all the right content, but if it's not set up in the style that the teacher wants it, you could lose all your points. And I would say the same thing if you go to a company. You could be the greatest programmer, but if you cannot conform to the style of writing that the company wants, then you might not have a job long. So because people have to review your code after you. So you want to try to write your codes where it's legible, where people can come back behind you, make modifications, and do whatever. Now, hackers at times, they'll come up with a signature and do whatever. That's different. But you want to work for a company, you're going to have to conform to what their rules are and whatnot. All right, so let's look at this. Validating your input. Now, many of our programs we wrote, pretty much all of them we wrote, we didn't have to validate anything, right? If I told you to input 2 numbers, 2 integers, you just input in numbers and it didn't matter the range or whatever. But now we can use the and the or but then with a while loop to determine whether or not a number is a valid number to be entered. So if we look at this code, so what I'll do, I'll just copy this code here, if I can. I'll take this code and I'll put it in the online GDB. All right, so I'll take it, I'll just leave the C, I'll leave that right there. Okay, and take this out, all right, and put this in. So let's see what we got here. So I'll take this and tab it over. So we have this information. I left X in. X don't have any valid reason being in. I just left it. But here we have CN, C out, enter a number in the range of, or the range 1 through 100. All right. So what numbers are valid? 1, and anything less than or equal to 100 is valid. Now we have to input the number. But look at our while statement. Now our while statement. Well, first of all, I need to change this. I'll just need to say int num, because num is not declared, right? Number. All right. So int number, because the computer don't know what number is. So this says while number is less than 1, okay, or number greater than 100, what we want to say, invalid range, invalid value in range, all right? 1 through 100. So when I run this, and then it what? It me to input the number again. So what happens? This while loop will perform until I put in a number that's 1 from 1 to 100. Okay, so let's run it, all right? Hopefully I got all the errors out. So here it says, yeah, I think what happened is at the bottom. That's what I don't like about this. Oh, that's this. All right, enter a number in the range. So if I put in, if I could type 1111, come on. All right, that's greater than 100. See what happened? Error, enter whatever, CN number. So now I'm stuck in this loop. How long? Until I put a number that's in the range of 1 to 100. I put in -5. Still, you understand? Anything outside that range is going to keep me in that loop. Now, what that does is that allows for either data integrity, and what I mean by that is you're making sure that a user gives you correct data, rather than give you a -5 and then it goes through the program trying to perform something with a -5, and -5 is not a valid entry for anything that's in your program, all right? So it kind of like keeps the data, the integrity of the data, of the input, or et cetera, so that you can what? Make sure you go into the proper module, doing whatever, not just getting any type data and then it's system bombing out later on. So if I put in 55, hit enter, bam, program completed. All right. Or if I could have had on continue, perform whatever statements to do whatever. All right. So that's what this says. So now we can what? Validate something. If I said I wanted to validate this to where I can only enter the numbers 20 through 30. So I would have to modify this, right? I would have to say what? Less than 20 and what? Greater than 30. So anything between 20 and 30, in the range of 20 and 30 would be valid, but anything else would be invalid. So you see how you have to decipher, and when they talk about doing math problems, how you have to decipher what's being said in a problem, and then put that problem into action or code in a program, right? And that's why with math, you get a lot of word problems. So they you could say, okay, I need to take this, do that, do the other, because you as the programmer have to think through the problem to come up with whether it's a while loop, a if, a for loop, or whatnot to perform the logic that you need to perform. All right. So what this saying is, okay, first read the value. Okay, this is the flow chart for what we just did. Okay, we input a number. All right, we read in the number. If the number is within 1 and 100, okay, we display no. If it's not, if it's in the range of 1 to 100, we continue. But if it's less than 1 and greater than 100, we display and read another number. Still, if it's less than 1 and greater than 100, we display an error message. So we're going to stay here until we get a valid number. When we get a number that's 1 greater than equal to 1 and less than equal to 100, okay, now we continuing on with the program to do whatever we have to do. And maybe that number that we entered, 1 through 100, is a number that we need for whatever reason. You know, it could be a number for some kind of reading that's needed. All right, or it could be like a number for a test score or whatever. But normally we would add 0 for a test score also. All right. So now, so in this program, you have a while loop, and what happens is the same thing. It got OR, but what they did was they use values, a minimum value and a max value, rather than use an actual number. All right, for a max value, they use 15. All right. So, and I'll go back to the program and show you how that worked. So this was what? How many players do you wish per team? And they say CN team players. Then they say while team player is less than whatever we had was, I think it was 5, and our team player greater than 15. So a team got to have at least 5 and no more than what? 15, right? And if that was the case, you should have at least 5, but no more than 15. So see how the program is being written to kind of express what you wanted to express, okay? And then please enter again. So you're going to stay in that loop until you enter a number from 5 to 15. Once you got it, then you say, okay, let's get the players, right? But what happens? It asks you what? How many players are available? CN players. So now, while players is what? Less than or equal to 0, what? Please enter a player. CN player. All right? CN players. All right? So here it get the players again. All right? Please enter players from 0 or greater. Now, then you're calculating the players' time divided by team players to get the number of teams and et cetera. So based upon all the information that was given. So see how you have your loop here to determine how many players per team. And then once you get the valid input, you say while players are less than or equal to 0, do this. Please enter players greater than. So see here, while this is less than 0, so they doing the error message first, right? So they asking the question to get the error. So if players are less than equal to 0, we're gonna stay here and keep performing this, all right? But then if it's not, then we calculate the different team number of teams by dividing the players by the team, and then doing the leftovers with using the modulus. Remember, we use the modulus to find what? Remainder, all right? And then it tells you have so many teams with so many players left over, all right? Now, let's go back to the program. So look here. We use the number, when we use this in this program. No, it's not this. Let me do Control Z. When we had X. All right. So here in this program, we had while X is less than 5, we could have done this. We could have did something like this. Const int max, right, equals 5. Now, and then we could say here, while X is less than max, if I could type. All right. So now what? I don't have an actual number here. I have max. So I'm starting at what? 0, and ending where x is less than and doing this loop while x is less than 5, which is max. So you can use variables to control your loop too. It don't have to be a constant number. All right, and that's some of the beauty about programming. All right, because sometimes you're going to have a value that you're going to have to test against. So a counter. A counter is a variable that regularly increments or decrement each time, decrement each time a loop iterates. So if we're looking at this loop, what is our counter? Our counter was being incremented is what? X. So X would be our counter in this program, okay? So X is what's being incremented each time we're going through the loop, and it's being used to test. All right. So, and like I say, we use a max. We use X, but we use a max value. But in this program they use a max value and a min value. And in their program they did what? They did int num is equal to min, and then num went from whatever num was the min value to less than equal to the max number. And I think you all wrote this program for an assignment once early in the semester. And this is the exact same program that actually do the squared. All right. So what happened is the max value is 10. All right. So what happens in here, it says while number, which starts at what? 1, it says what? And you had to enter. Did you enter something? No, you didn't enter anything. But it said while 1 is less than equal to 10, it wants you to output num, which was 1 the first time, and then output 1 times 1, which is the square, which is what? 1. Then it incremented, went back through. Num becomes 2. And then print out 2. All right, here print out 2. And then print out 2 times 2, which is 4. So that's the square. And then on and on and on till it got to 10, which 10 times 10 is 100. So that's all that program did. And like I said, you can type those programs to see how they work and whatnot. Now, the do-while loop. Anybody have any questions? So far, any questions? All right. The do-while loop. The do-while loop works similar to the while loop with one exception. The do-while does not test before performing the statements in the loop. It will automatically perform whatever statements you have in the loop, and at the end of the loop, it will test to see if it needs to perform it again. Okay, that's the only difference. You still have your starting point, you're still going to have your increment, and you're still going to have your expression. Okay, so this is the format. Do whatever your statement or statements is, and then your expression and semicolon. You got to be careful. You got to have that semicolon at the end. All right. Now let's go and let's write that program. All right. So let's look at this code here. We have this while loop, and this while loop's run. Let's run this while loop again, and it's going to go from whatever the max. Max is 5. So it's going to perform 0 to 4 and kicks out at 5. Now, let's take this program and convert that while loop to a do. All right. To do that, I would take this information, all right? I would cut it, and this becomes what? Tested at the end, and I need to put what? A semicolon. Then I simply go to the top and put do where I had while. And that's it. But remember, I have my increment in there. I have my starting point. I have my test, which is at the end, but I also have my increment, right? So everything is basically the same, except that it will perform the statements first at least one time. And if the statement holds true, then it continues. All right, so let's run it and see what we get. All right, everybody see that? Exact same output, right? Same output. What we did, we took a while loop and we turned it into a do while, all right? Now, you say, okay, well, Mrs. Vegetable, what's the purpose? Why, whatever? You're saying it's going to perform anyway. What if I put 770 here? What happens? How many times will it perform this information here? It will perform it only one time. I run it because what? It's going to see out 70 and BRCC, but then it's going to say if 70 greater than less than max? No. See? Only one time. So it will perform at least one time. Unlike the while loop, and what I'm going to do, I'm going to do Control Z. Unlike the while loop, where the while loop, it will test first, and then if it's true, it falls through. So what I'm going to do, I'm going to set this value to 70, right? Now, what you think going to output? The only thing that will output is program complete. That's it. Because what? The pretest will not allow it to perform anything. So you see the difference between the while loop? The while loop will test to see if X is less than max. If it's not, hey, I'm not performing anything. The do while, on the other hand, will allow it to perform those statements in the while loop, the do while loop, and then at the end test. So you will perform it at least what? One time. Okay? Any questions? Any questions? So they work, I mean, identical. Like I say, you got your starting point, you got your test condition and your increment. And with the do, it was the same way. All right. If I go back. Oh no, I'm going backwards. I don't want to do it backwards. I got to go forward. All right. So, but const int max equal 5. All right. So now let's go back to the notes. So that's the do while, and let's look at this. This is a while they're showing. The while loop is set up to where, and like I say, it don't have the increment, so that's kind of confusing. So you got int x equal 1, while x is less than 0. X is not less than 0, so it will not perform that. It continues. On the other hand, int x equal 1 do. It will do this regardless, but then is 1 less than 0? No, it kicks out. So this one will output x. This one will not output x. All right, so it just said, what we doing? We performing the statements first, then we asking a question or testing the expression to see if it's true. And if it's true, we performing it over and over again. If it's when it's false, we end it. So that's the only thing we to do. So looking at this program has a do while in it, all right? So here we say do and then while. Now this program, as I said prior to it, this will allow the user to perform these statements as long as the user input what? Y or uppercase Y or lowercase y. So this loop does not have a number of times specifically as to how many times it's going to execute. As long as the user put in Y, it will continue to execute. All right, so look at this. In this program, a person will input 3 scores and then it will find the average. But after finding the average, they are prompted to see if they want to test or input and find another average. All right. So if we go back to this program, and we go to the do, all right. So we'll do something like this. We'll say something like do this. And let's say something, we do C and number. Okay, we'll do something like, we'll do int num1, int num2. and the average. So what happened, we'll do a do, all right? And I could have took this out. All right, then I'll do this do, and I'll do C out. Number, and the first number, all right? C in num1, all right? Then C out. Right tight. See out second number. Right. Right. So now, then in here I could say if num2, remember? I could just do num2, because if it's num2, then I want to say what? Average is equal to num1 divided by num2. All right, and I made average integer, so and then I can do else say equals 0. I'll just set it to 0 because it's undefined. All right. So now, when we go here, now we can see out average. I'll put an A. Average. We'll do this in line here. All right, so we'll output average, but now we don't need this, right? But we need what? Well, I need to go back and add something like CH, a choice, right? Equals Y. And I'll just do the 1 rather than the uppercase and lowercase, all right? So choice, and I want to do all that, all right? And then I want to say, wow, call it CH is equal to Y, all right? Semicolon, all right? So here I got I got choice. While choice is equal to Y. Equal to Y. So after I find my average, I want to do what? I want to ask the question. Then what? Choice. All right. So now, I'm going to input some numbers, right? Once I input the numbers, I'll find the average. It's going to do it the first time. It's going to input num1, input num2. If num2 is any value other than 0, I'm going to what? Divide num1 by num2, get an average. Else, average, I'm going to just say average is 0. It's undefined. All right? Then I'm going to output the word average, and then I'm going to output average, the actual average. Then I'm gonna prompt the user to what? Input to choose whether or not they want to perform the loop again. So let's run it. All right, I think I got all errors out. Hopefully. No. Let's say it num1. Oh, I got x equal num1. All right. So take this out. All right, num1, and I don't think I use x in the program. All right, so enter the first number. Say I enter 10, all right? And the second number, I enter 2 and hit enter. I hit enter. All right, it gives us what? Average 5. Now, type Y to find another average. If I put Y, see, enter first number. So what happened is it will continue to perform this loop until I type in any other character other than the lowercase y. So then I'll put 100 and I'll put 3. All right, it give me 33 and why it's not? Why I can't say it, okay. All right, then it say what? Another average. I could put Y, it will perform it again over and over and over and over. But if I put any other character other than Y, it kicks out, program completed. All right, so see how your loops can work to kind of make your program work to where you can control the user. Hey, do this. Hey, if I don't put the right whatever, do this. Because I could have made it to where they put in the Y until, well, perform until they put in a correct letter. All right, so any questions about that? All right, so that's what happens here. This loop will perform as long as they put in a lowercase y or an uppercase y. All right, and if you notice, I set choice here to y, but I didn't have to do that because what? The do says what? Automatically perform this one time, and then what? I'm inputting choice before I do what? Test it. So I did not have to initialize it to y, okay? But if this was a while loop, it would have to be initialized. So it didn't really have to be initialized, okay? All right, and that's just the example. Now, using a do while with menus. Now, you've written programs. We kind of went through modules a little bit, but do while with menus are good because what happens is, this is the class time. All right, do while work with menus because because what? Normally with a menu, you want to display that. If you want to go to a module where it displays a menu, you don't want to have it test to see if it goes in the menu. You know that you want to display the menu. So you would have a do that says, okay, display the menu. But based on the choice, then perform something else. If the choice not valid, display the menu again. You understand? So that's the beauty of using a menu with a do rather than a while loop. All right. So you'll display the menu. If it's choice A, I might be performing some function. If it's B, another one. C, another one. F, what? 1, 2, 3, 4, and 4, I quit. But if I put in an invalid, I could have it where if I put in an invalid choice, display that menu again. Display that menu again until that user what? Give me the proper code, proper value, and then go on. All right. So you see how you would be making your program a better fit for a company, because many times you have users that might type by mistake sometimes, type in the wrong choice. And then if your program is still performing something with a wrong choice, then it could end up caught up in some kind of hang up or whatnot, because that choice might be used to do something. All right. So anybody with any questions? Questions? Let's see. This is the notes. We got the 5.8. This the case statements. The for loop. Okay. Let's look at the for loop just for a moment. This is the last loop, and then next class period we'll complete it, and then I'll post a test. All right. So with the for loop, all right, we have this what? Do. All right, well, let's go back. I don't want to do that. Let's go back. Go back to that other loop we had. All right. All right. Come on. All right. All right. So here we have this do loop. All right. Now this do loop. No, what I took the while off. Let's see. All right, here we go. This while loop. This while loop performed what? 5 times, right? But we could take this loop. No, and remember, we had what? We had a starting point, a test condition, and our increment or decrement. So with a for loop, I could perform this 5 times with a for loop. I could say for int x equals 0, x less than 5, x plus plus. But now what? Now I don't need this, and I don't need this, because what? Everything is in this for loop. Everything. My starting point, my test, and my increment. So when I run this, it's going to do it 5 times. So with a for loop, I can specify based on how I write my condition, all right, my test, how many times I want my loop to perform or iterate. If I wanted to do it 100 times, for x equals 0, x less than 100, x plus plus, all in that one line. Bam, I've done it all in that one statement. Remember, 0 to 99 is 100. So see how a for loop, unlike the while loop, everything is placed in that header. All right. A while loop, you have to declare the variable outside. All right. You have to increment within the loop, in the body of the loop. All right. But with the for loop, everything is in that particular loop header. The starting point, the test, and the increment, and it could be decrement. Because I could say, okay, I want to go from 100, if I could type, 100 to greater than 0. But I have to change this to what? Minus minus, because I'm doing 100, 99, 98, 97 until I'm getting to greater than 100. So when I run this program, you're going to see from 100 to 1. See? It's going to go from 100 all the way to 1. See? So that's the loops, all right? Now, class is over. I can go look at, we can look at the assignments that I'll post. Let's go to the assignments. But class is over. Like I said, I don't want to hold you too long, but let's review. I'll go over the assignments that I want to give you. I think I went over them already, but I'll post them, but I'll assign them on next class period so that you'll have them to do. And like I said, we'll complete the chapter, take the test, have the test for that week, and then we'll move on to the next chapter. Because in this chapter, we're also going to deal with data files. All right, but I haven't really went over the data files yet. All right, so here, look what we have. Oh yeah, it's dealing with the data file. And we never went over that. We're gonna go over that next class period. So, oh man. What I'll do. No. But I thought I had a for in a while loop. I might post something, because these two programs deals with data files. And I don't want you to no. Data files. Yep, see, they all dealing with data files. Yep, reading from it, and I gotta show you some stuff because you gotta know about the file location, whatever, creating an input file, output file, or creating an output input file, writing an output file, where to find it. So we'll go over that on next class period. And what I'll try to do I'll probably try to log in like maybe half an hour earlier and go over data files and then the programs that I'm assigned, and then we'll get to the class, and then at the end of the class we'll get to data files where you kind of have an understanding of what's going on. All right. So any questions? Anybody with any questions? Any questions? No questions? All right, I'll see y'all on next class period. Okay, but I might post 3 assignments for y'all to do, or one. I might post 1 assignment, and I'll give you a choice whether to do a while, a for, or a do. So it'll be up to you to which one you want to do, but you can choose which one. All right. So I'll see y'all on next class period.